Dart skill presents proofs and conjectures. A conjecture is a hypothesis, meaning it's a statement that is likely to be true, but no one has ever been able to prove or disprove the same. Once a conjecture has been proved, it becomes a theorem. Let's look at a few useful properties. If the three angles in a triangle are equal in measure to the three angles of another triangle, the two triangles bear the same ratio of their corresponding sides and are said to be similar. So if we have two triangles, let's name this as ABC and this one as PQR, and let's also say that angle B out here is the same measure as angle Q. Angle C is the same measure on the smaller triangle as angle R on the larger one. That would automatically imply that the third angles have to be equal, because the three angles in any triangle have to add up to 180 degrees. And when this happens, we say the two triangles are similar and the corresponding sides bear the same ratio, which means if you take side AB, the two angles on that side are this one and this one. So if you take the same side on that other triangle, having this angle Q and this angle P, and take the ratio of AB and PQ, AB over PQ, that's going to be exactly equal to the ratio of BC over QR, and then that is equal to the ratio of AC, the third side, having the angles A and C, to this side PR on the larger triangle, having angle P which is congruent to angle A and angle R which is congruent to angle C. Sometimes you get questions like, if this is 5, this is a 10, and if this is 3, how much is this? What is the length of QR? So because AB over PQ is 5 over 10, that is 1/2, and that 1/2 is going to be the ratio of all the corresponding sides. That includes BC over QR. So 3 over QR is going to be 1/2. That will give you the length of QR to be equal to 6 units, whatever that unit is. If the three sides of a triangle are equal in length to the three sides of another triangle, the two triangles are congruent in every respect. And that, I guess, is pretty obvious. If you have a triangle and you have another triangle with the same exact length of the three sides, then obviously the two triangles are congruent, meaning they are exactly identical to each other. Congruent means the same exact or identical. If the two sides of a triangle are equal in length to the two sides of another triangle, and the included angle, this is important, the included angles between the two equal sides are also the same measure, the two triangles are congruent. Now what that essentially means is, you have a triangle. These are the two sides on a triangle. I'm not going to draw the third side. And then you have the two sides of another triangle. And let's say this side is the same length as this one, and this side is the same length as this one, and this angle is the same measure as this one. The included angle means the angle between the two equal sides. Now if you go on to complete the two triangles, the triangles are congruent, which essentially means this side is the same length as this one, this angle is the same measure as this one, and this angle out here is the same measure as this one. And this is commonly known as the SAS condition, which means that two sides and the angle between them on one triangle has to be equal to the two corresponding sides and the angle between them on the other one. If it isn't the included angle that are equal between the two equal sides, there's no guarantee that the two triangles would be congruent. So this is SAS. The previous one was SSS, three sides on one triangle, is equal to the corresponding sides on the other triangle, and it would imply that the angles are also equal if you can just prove the three sides are equal in length. If two triangles have two angles on one equal in measure to two angles on the other, and also one side is equal in length to the corresponding side on the other, the two triangles are congruent. So if we have a triangle and we have another one, let's call this ABC, and this one as XYZ. If you have two angles on one equal in measure to two angles on the other, which means, let's say this angle B out here is the same measure as this angle Y, and this angle A is the same measure as angle X over here, two angles, and let's say this side is the same length as this side, which means the side opposite to this angle, angle B, is the same measure as the side opposite to angle Y, then we could say that two triangles are congruent, or they're exactly the same, identical in all respects. And we call this the ASA or the AAS, angle-angle side congruency condition. You may want to note that the corresponding sides on the two triangles have to be equal in length in the angle-angle side condition, which means that if AC were to be equal to another side not XZ on this triangle, let's say the length of AC is the same measure as this YZ and XZ is something different, that doesn't fulfill the ASA or the AAS condition because the corresponding sides are not equal. Let's look at a problem. ABCD is a parallelogram. X and Y are points on the diagonal BD, so that BY, the length of BY, is equal to the length of BX. We need to prove that the quadrilateral AXCY is a parallelogram. Let me first try and draw the picture. We have a parallelogram. So this parallelogram is named A, B, C and D. These 2 points are X and Y. BY, so B to Y, this is Y, is the same length as DX, D to X. And we need to prove AXCY, AXCY is also a parallelogram. How do we go about? Now if you look at the triangles CDX, this triangle out here, triangle CDX, and triangle ABY, this one, the length of DC is the same length as that of AB because they're the opposite sides of a parallelogram ABCD. The length of DX, this length, is the same as the length of BY. That's given in the problem. And then we can also say that the measure of angle CDX is the same as the measure of angle ABY. CDX is this angle out here. It's the same measure as this angle because this diagonal DB acts as a transversal between the two parallel lines DC and AB, and therefore they are the alternate interior angles. So here we have on this triangle two sides, this one and this one, are equal in length to the corresponding two sides on this triangle, and also the included angles have the same measure. So the two triangles are congruent, SAS, and therefore we could go ahead and say that the length of this XC is the same measure as the length of this AY. They are the same length because the two triangles are congruent. And in the same exact way, if you look at triangle ADX and triangle CYB, so we have this side the same length as this side, the opposite sides on a parallelogram. So we have AD the same length as BC, dx obviously is equal to by given, so dx is equal to by, no problem with that. And finally, this angle out here, angle ADX, angle ADX is the same measure for the same reason, alternate interior angles with angle CBY, angle CBY, and hence this triangle is congruent to this triangle by the same condition SAS, and therefore AX has to be the same length as CY. So here we have the opposite sides of a quadrilateral equal in length, and that has to be a parallelogram.